All right, hi everybody. So I'm gonna make a couple quick videos, hopefully, about the skeletal system. Some of the stuff that I normally will draw in class for my other classes, I'm gonna draw out for you guys. I would recommend, again, take this PowerPoint and draw along with me. So in these couple of videos that I'm gonna cut into hopefully about 10-minute chunks, I'm gonna do compact bone versus spongy bone. And then I'm also going to show you where to find compact bone versus spongy bone in different types of bones, so long bones and then a non-long bone. And when I do compact bone and spongy bone, and then the anatomy of long bones versus non-long bones, I'll show you where to find the different types of bone cells, because often that gets a little bit um, complicated. Then I'll do another video about fetal bone development because that's actually one of the more complicated processes or two processes for the skeletal system. You do want to understand how bone cells at different locations are going to help with the growth of the bone during childhood, as well as how that helps with remodeling in the adult. So I'll make a separate video for that one as well. So let's start off with, okay, so I'm going to have a long bone and a non-long bone. So the non-long bone here, this is the sternum. This is going to be a flat bone. And I'm going to have my long bone here is kind of what my humerus would essentially look like. So first thing we want to think about is what are the two different types of bone tissues we have, and then how those bone tissues are arranged in our different types of bones. So over here, we can draw our compact bone. And then over here, I can draw my spongy bone. So you want to think about the different features of each of these. Okay, the compact bone, remember, is going to have a circle in the center, and that's our central canal. And then around the central canal, we're going to have our osteocytes that are going to sit in their little lacuna pockets. So we're just going to draw that. And then basically what happens is, I don't have brown, but I'm going to use this kind of reddish color as brown. The osteocytes are inside of a layer called the lamella, like that. And so they'll be surrounded by bone, but they're going to have a little bit of a pocket around them that keeps them separated from that bone tissue. So we're just going to create another layer and then another layer, essentially like that. And of course, each of these layers is going to have osteocytes inside of their lacuna. So this whole component is called an osteon. Remember, we have our central canal, which is where our blood supply is going to be. And then we have our osteocytes in lacuna. Lacunae is actually the pluralized version of that. Sorry, my handwriting is a little small. I'm trying to make enough space for all my drawings. And then this part here, so from one layer to another layer, this is the lamella, or the lamellae, which has an E at the end, is pluralized, okay? Just think about this is going to be a nice long cylinder that comes down like this that's going to run the length of the bone. And so compact bone has multiple osteons all combined together. Spongy bone is going to be different though. So I'm going to start with, in the center, I'm going to have an osteocyte that's inside of the lacuna. And then I'm going to create another area, so kind of an irregular circle that is going to have more osteocytes and lacuna. And then going between the osteocytes and the lacuna, that's going to be our hydroxyapatite crystals that creates basically one layer or lamella. So I can create another layer or lamella, and you'll start to kind of see how these are more irregularly shaped. They're not like perfect circles. And each of these layers is going to have the osteocytes in the lacuna, just like the compact bone did. So there's not a whole lot of differences. The differences are, you should see in the center, they don't have a central canal. right? I didn't draw a central canal at the center with blood vessels. They still have osteocytes in lacuna. And they still have lamella. The difference here is, though, you're not going to have all of these units called osteons. These are now trabeculae. So those are trabeculae. And what you'll see is over here, we're going to build like another osteon, which is going to be like right next to that one. And in this case, we're going to build another trabeculae that's going to be far apart from it. So there will be space between our trabeculae. This open area space is going to be where the red marrow is going to be stored. And then another difference is we're going to have an outer layer on our spongy bone, and that outer layer is going to be connective tissue. That is the end osteum. So just underneath the fibrous layer of the end osteum, this is where we're going to have our osteogenic cells. So this is where we have osteogenic cells, osteoblasts, and like some osteoclasts. So we'll have osteoblasts, and this is like an osteoclast. And then we're going to have like some osteogenic cells. So what you should see is we can build our bone, our trabeculae outward and inward, but our compact bone is only made of osteocytes. So it's actually going to be harder for you to make new rings on the compact bone. We're going to have to see that when we make compact bone, we have to do it from a periphery or from an outer edge. So those are our two types of bone tissue. What you should see is that based on long bone versus a flat bone, we're going to have different areas where we're going to find compact bone and spongy bone. So for my compact bone, it's always going to be on the outermost layer. So just imagine for the sternum, I took a frontal section and I'm looking at the inside of the bone. I'm going to see that on the outside layer, I'm going to have a solid area that's going to be my compact bone. Just like that. And then going between the compact bone layers, I'm going to have spongy bone. So I'm going to make this kind of hash marked because I want it to look like it has holes in it. This is going to be a little bit different than the long bone. So remember, in a long bone, we're going to have like two epiphyses and we're going to have a diaphysis. So we have our proximal epiphysis and our distal epiphysis and then our diaphysis. What we're always going to do is fill the outer edge with compact bone. Because remember, compact bone is nice and solid, it's nice and rigid. And as I fill that outer layer with compact bone, essentially I want that to give me the strength and the rigidity that I need to bear weight on that bone. Just like I kind of tried to explain in class, is imagine trying to build your building with solid metal beams. That's great structural support. However, it's really heavy, so moving those solid structural beams is going to be more difficult. The same thing with our skeleton. Instead, we want to put the solid part on the outside and then fill it with something that is lighter. We are still strong and we can bear weight, but we're not as heavy. So this is where you're going to thicken your compact bone here at the diaphysis. Okay, so that black line would also be compact bone. I just didn't want to make it in black. So it's going to be my compact bone. And then I'm going to have the middle part of my bone is going to be where my medullary cavity is. And you can basically cut this in half if you want to. And we can look at the difference between a child's bone and an adult bone here. So in the epiphysis, we're going to have spongy bone. And again, in the epiphysis, we're going to have spongy bone. And what you should notice is that where the spongy bone and the compact bone are going to come together, there's kind of an area right here. It's like about an area right there. The same thing is true for a flat bone. There'll be like an area right about there, and there's an area right about there. How are you going to know this? I don't expect you to necessarily know this, but you should know it for a long bone. This area is either going to be bone or it's going to be cartilage. So we're now going to add the next type of tissue to our bone. So the next type of tissue is hyaline cartilage. Hyaline cartilage is going to be on the outer surface. So on the superficial most surface of the epiphysis, where your two bones are going to come together. So this is why this is called articular cartilage, just like that. The other place we're going to find hyaline cartilage is in our child's bone. So I forgot to put my label. This is my adult, and this is my child, that side. So on the child side, we're going to make this area here hyaline cartilage, and that becomes the epiphyseal plates. This is where we're going to grow our bone lengthwise. When you stop growing, that cartilage actually gets made into more compact bone, and this becomes the epiphyseal line. That's the whole idea. Then we're going to add one more type of tissue here. So the other type of tissue I'm going to make in my same blue color. So remember, this is made of trabeculae. So each trabeculae is going to be lined with end ostium. So that's going to be all where my end ostium is. And in the adult, again, I still have end ostium. Right, like that. I'm just not going to make all of them with end ostium. And they'll be on the other side down here as well. The end ostium is also going to be right here in the inside of the medullary cavity. And you want to remember deep to the end ostium. So you want to think about this structure that I created right here is basically that part right there, the trabeculae with the end ostium. The same thing is going to happen here. So just deep to the end ostium, this is where we have our osteoblast, osteoclast, and our osteoprogenitor cells, like that. So all those cells are just right there. Because remember, we want to build our compact bone, and the only way to build the compact bone is on the superficial most layer. Because here, I have too much bone already. I can't add those extra layers. This is going to be the same thing for all of our flat bones too. So here we'll see that the end ostium is basically going to surround all of our trabeculae in our spongy bone, just like that. Okay. And then you will have either an epiphyseal plate right here in our flat bone, or we'll have an epiphyseal line. Depending on if this is an adult bone, you stopped growing, or you're still a child's bone. So just remember, I cut this in half, so don't get confused. Child versus the adult, child, adult. Like that. Okay. The other thing we're going to add is a couple more types of tissue. So in the adult, in the medullary cavity, I'm going to make this yellow because this is yellow marrow. For a child, this is going to be red because this is where I store my red marrow. And then always in the spongy bone, so basically just superficial to the end ostium that's going between the trabeculae, again, this is where I have my red marrow. This will be the same thing as in flat bones. So some of our flat bones will also store some of our red marrow for our adult and for our child. So you should be able to see a couple of differences here. The last thing that I forgot actually to put on here is the periosteum. So the periosteum is going to be the connective tissue that goes on the outer surface of the bone, basically where you don't have your cartilage, right, like that. You'll have a periosteum in the adult and the child. And just remember, deep to the periosteum, this is where I'm creating my osteoblasts and my osteoclasts, because this is where my osteogenic layer is. So the same thing for the adult. This is going to be where my osteogenic layer is, where my osteoblasts and my osteoclasts are. Okay, so hopefully this one helps you kind of see the differences between the tissue and then like where those tissues are located on the non-long bone versus the long bone. And then we're going to look at how these how a long bone at least grows in length.